In our final video for Chapter 8, we're going to go through all the steps of a two-proportion hypothesis test one more time. So it says a study used nicotine gum and patches to help people quit smoking. The study was randomized and double-blind. Each participant was interviewed after 28 days, and success was defined as being abstinent from cigarettes for 28 days. The results showed that 174 out of 1,649 people using the nicotine gum succeeded, and 156 out of 1,648 using the patch succeeded. We want to conduct a hypothesis test to see whether or not there is a difference in the results of the gum and the patch. My key word here is difference. It doesn't specify that the gum is better than or gum is worse than the patch, just as there's a difference in the results between these two. I've got two groups, a nicotine gum group and a patch group. Therefore, I'm going to do a two-proportion hypothesis test. For my hypotheses, my HO will assume the two groups are equal. So I'm going to say P sub G for the gum is equal to P sub P for the patch. The population proportion of those who use the gum and are able to quit smoking is equal to the population proportion of those who use the patch and are able to quit smoking. My alternative assumes that there is a difference, that they're not equal in the results. One is better than the other. Now, all of my hypothesis tests in this class rely upon using the theories of the normal sampling distribution, so I need to make sure I can use that distribution. Check the central limit theorem components that we're concerned with. Can I say the random sample criteria is met? I can, because it says right here it's randomized. For my gum group, my success number is 174. It says right here, the results showed that 174 out of 1,649 using the gum succeeded. To get my failure number, I take my sample size of 1,649, subtract my success number of 174, and we get 1,475. Both numbers are over 10. Those numbers are met. Same steps for my patch group. Success number is 156. The failure number will be 1,492. Again, they're both over 10. So my central limit theorem is met. I could use the normal sampling distribution. Again, 0 should be in the middle for a two-proportion hypothesis test. This is going to be a two-tailed test, so I'm going to look at both sides here. Next thing I'm going to do is find my values, my z-score, my p-value, sample proportion for the gum, and sample proportion for the patch. To do that, I'm going to go to stat test number 6, the two-proportion z-test. I've already got my numbers filled in to save some time. For the first group, for the gum group, x1 is 174. The sample size was 1,649. For the second group, the patch, it was 156 out of 1,648. I'm going to use the not equal to symbol based off of my alternative and the word difference. When I calculate this, you can see my z-score is 1.04. I'll round that to 2 places. My p-value is 0.2989. For my sample proportion for the gum for the first group, 0.105 around to 0.11 or 11%. For the gum, 0.094 around to 0.09 or 9%. So I can see 11% of those using the gum were successful, 9% of those using the patch were successful based off of these samples. Now that's not a big difference. I mean, 11% success compared to 9% success. I could take another set of samples and I might get 9% for the gum and then 11% for the patch, so it could be reversed. So it seems that there's not a lot of evidence to say that they're not equal. There's not a big gap here, but the p-value will have the ultimate decision-making power here. To compare my p-value to my alpha, my p-value is 0.2989. It's about 30%. In the problem here, no alpha, no significance level was given. The typical alpha, as we've seen, is 0.05. So if one is not given, it's safe to assume you can use 0.05 in my stat lab. So 0.29 compared to 0.05, 29.89% is greater than 5%. So when the p-value is greater than alpha, we do not reject HO. This is not thrown out, but this is kept. The data are not statistically significant to conclude this idea that there is a difference. They are close enough together that they seem to be equal in their results of helping people quit smoking. So I would say the data are not statistically significant to conclude there is a difference in the results of the gum and the patch.